procedure call, a third, a recursive call with factorial of 4 minus 1, which is factorial of 3, right? So that initiated this third one, factorial of 3. Once again, 3 is not equal to 0. So else block. Once again, this 3 into something, this multiplication is on hold because we are supposed to compute factorial of 3 minus 1. Right? What is now 3 minus 1? It's 2. So again, factorial of 2. A fourth procedure started its execution. These 3 at the top, right? These blue color 3 procedure calls, they are not yet complete. They are waiting for something to come back to them. Okay, they are waiting. They are waiting for some result. Okay. So this one started. Once again, 2 is not equal to 0. So else block will execute. In else block, again, 2 into factorial of something, which is again, we have to compute. So again, we have to put this one on hold. Start next procedure call, factorial of 1. Once again, 1 is not, 1 is not equal to 0. So again, else block executes multiplication, 1 multiplied by factorial of 1 minus 1. We have to compute that. So a sixth procedure call started over here. So in that sixth procedure, now we have something, right? Now we have value which is 0. So if 0 is equal to 0, now we can return 1. Now else block is insignificant here because now if block will execute. 0 is equal to 0, return 1. Now this is the place where you should understand where this return will be, where it will go back. Usually what happens, whenever we say return, it goes back to the original code, right? I mean, whatever pseudocodes we have studied, there is a main code and then there are 1 or 2 procedures. And whenever we call a procedure, computer executes that procedure and come back to original code. But in this case, we are not talking about original code because who initiated this particular procedure, this red color procedure, this line over here, this factorial of 1 minus 1. Because of this particular line, factorial of 1 minus 1, this entire red colored procedure started its execution. And because of that, when we say return 1, this 1 should be returned back over here. Can you see my pointer, mouse pointer here?
Yes, sir.
Yes, sir.
This is the part, this is the place where that 1 should go back. Because this procedure execution initiated because of this line. So
Yes.
wherever it initiated, that is the place where the return value should go back. Okay. If it is started in main procedure, in main pseudocode, it should go to main procedure, main pseudocode, which we have studied till week 10. But now this is a different structure, right? The main code, pseudocode is not executing this. Who started this? This particular small part over here, factorial of 1 minus 1. And that is the reason this returned value 1 will go over here. This line, right? Factorial of 1 minus 1 will be replaced by this value 1. Like this. And now this incomplete execution with something which we put on hold earlier, right? We said earlier when we were at this stage, we said 1 multiplied by something. We cannot compute that until we know what that something is. But now we know what that something is. That something is 1. And now it is easier to compute 1 into 1, right? I mean, it's possible. Earlier it wasn't even possible. Now as it is possible, we will compute 1 into 1, which is once again 1, right? And now as this is 1, once again, where this will return?
It will return at 2.
Factorial
place,
2 minus 1.
Correct. The place where this procedure call was started. Where this procedure call was started, factorial of 1, it started over here. Factorial of 2 minus 1. So this multiplication result should go back over here. Are you getting my point?
Yes, sir.
Yes.
Yeah. So that is the reason now I will replace this factorial of 2 minus 1 with this multiplication, which is 1. Same thing will be followed again. Now we know the computation is 2 into 1, which is 2. But who generated from where this factorial of 2 initiated? At this place.
At that
Factorial of 3 minus 1.
3 minus 1
So replace this factorial of 3 minus 1
by
with
2.
this computation of 2 into 1. So that's the updation. Same thing. Now 3 into 2, 6. This 6 should go back the place where this factorial of 3 was initiated, which is over here.
4 into 6.
So this factorial of 4 minus 1 will be replaced by 3 into 2, which is 6. And it will become 4 into 6 now. Sorry, there is an additional bracket here. Please ignore. Okay. I think in typing, I must have mistyped it. So anyways, so we have this 4 into 6 here. That will be computed, and that result will go back where? The place where factorial of 4 was initiated, which is over here. Factorial of 5 minus 1. Now it became 24. 5 into 24. Now this is the place where we compute that final answer, which is 120. And now this will return back to original pseudocode from where we started this factorial of 5. Wherever that code is. Okay, that is usually about the procedure, as that's the standard which we have followed. So there will be some line over here. Result is equal to factorial of 5. Yeah. Your question is?
My question is answered.
Answered, right? Yeah, that's why I said just hold on for 5 minutes, it will get answered.
Yeah.
Okay,
Sir,
and that's how we will get the, just hold on, hold on. That's how we get the final answer. Okay, so any doubts with recursion, please let me know.
Sir, if we have written 5 is equal to 1, then also it will give correct result, isn't it? And second line, sir.
Where?
In second line, sir. Second line. Line number 2. If 5 is equal to 1, then it will give the same result in less
That time,
computation.
sir, it will, I mean, the procedure will call itself only 5 times instead of 6 times, right? If it is
Yes, I got your point. So you are saying our base condition is currently is based on value 0. We should replace it with 1, right? That's the point.
Yeah. Yes,
but the problem with that is, what if your input is 0? Then your procedure will not be able to handle that input. Okay. Mathematically speaking, factorial exists for every positive number and including 0. I mean, every non-negative number has a factorial. Okay.
Okay.
That is why we should write a procedure which accommodates all non-zero integers.
Sir, then factorial 0 will be 0.
No, factorial of 0 is 1.
Okay.
It is 1, no?
It is 1, right? Well, that's what we did earlier. Just look at this red color one. If 0 is
I understood this. I understood this.
Okay, so factorial of 0 is 1. Mathematically, that's the case.
And sir, if we call factorial of negative number, it will give error, or this recursion will go up to infinity.
Actually, this code will go into infinity. So ideally, this procedure should not be even called if the input is negative. We should check that outside this procedure, if the number is negative, we should not even call this procedure, because factorial of negative number doesn't exist. It's not defined.
So we will say if someone asks, we can say that recursion will go up to infinity, or we will say that compiler or interpreter will return error.
No, I mean, there will not be error. If purely based on the given pseudocode, of course, it will go in infinite state, which is not ideal one. But that's why I said the main pseudocode, the calling of this original procedure pseudocode is not there, right? Ideally, in that pseudocode, we should first check what is the value, whether it's a negative value or not. If it's negative value, you should there itself you can print some message saying invalid input or something. Okay.
But sir, that is why the base condition is there for.
Correct, but base condition is exactly equal to 0, right? We can. So sorry, yeah. So But that base
then-
condition will not be able to handle negative numbers, right? So if that's the case, we'll have to add additional base condition. If number, that is n, is less than 0, then maybe print invalid input. So we can add one more if block, and that will solve the problem within the procedure.
Sir, in case of this pseudocode, if negative number is inputted, then it will return error, or it will never end. What will be
It
the
will never
answer?
end.
If such
It will never end. It will never end. As per this pseudocode, it will never end. Because it will continue to do this -1, -1, -1. It will never go into base condition. See, any pseudocode in any code, right? If it is not entering inside base condition, then it will be infinite loop. Okay.
Okay, sir.
And that is why we have to be very careful while writing a recursive procedure, because recursive procedure very easily can result into infinite loop. Okay.
What value it is taking and where it is terminating. These two conditions we should be mindful of.
Yes, correct.
Sir,
Yes, Tarika.
can you please explain that palindrome one with recursion, please?
Okay, I'll come to that. Let me first finish this one. Yes, Tarika, you have raised your hand.
Sir, first of all, very well explained this pseudocode. And sir, I wanted to ask, can you please explain what is mutual recursion?
Okay, sure.
Sir, with the pseudocode.
I don't have any pseudocode with me right now, but
Or maybe with some example, okay.
Yeah, it's not complicated. I'll tell you. Okay, I got palindrome and mutual recursion. I will explain both. I mean, I may not have ready pseudocode with me right now for either of these two, but I will explain both of those. Okay, I got the point.
Sir, would you mind sharing this PPT with us?
It is already there. It's part of week 12 content. Week 12 has the tutorials, right? So this is one of the slide used for that tutorial.
Okay, sir. Thank you.
This means you haven't watched.
Yeah, that's why I thought I saw somewhere the tutorial, not able to remember.
Yeah, this is I only recorded that tutorial.
That's why I saw this before, but now I get it.
It's there, right? It's already there, but you know, recorded content and live explanation always
totally
is different, right? Yeah, that's totally.
Yeah. So yesterday, Deepak sir was showing some PDF. So it is not available in our dashboard.
Okay, I don't know what Deepak was sharing yesterday. So I'll check with him. I'll ask him if it's not there. Maybe I'll ask him to put it on the dashboard.
Actually, there was some error with some student. It was showing, and for some it was not showing.
Okay. Anyway, I mean, I'll check with him that I will check with him what exactly he used yesterday.
No. I am not talking about that, Ritik. That was in degree, out degree PDF. You remember that?
Yeah, I remember that.
Yeah, that PDF, is it available?
I did not check actually.
Yeah.
Okay, all right, Prashant. Prashant, don't worry. I will check with. I mean, after the session, I will check with Deepak. Okay. So
thank you, sir.
I will ask him to upload that on the portal. If it's already there, fine. If not, we'll get it uploaded. All right.
Yeah. Thank you, sir.
Sure. Thanks. Yes, Prashant.
Sir.
Yeah,
sir. Sir, in the base case, can't we write if n is equal to 0 or equal to 1, return 1?
No, that's why I said, right. If we say a 1, right, then if your input is 0, then that condition, that input cannot be handled by your code.
Sir, both we can mention, sir. If n is equal to 0 or n is equal to 1, return 1.
Okay, yeah, that's possible. You can do that. That is okay. That you can do. So as I said, right, see, this is the part which we have studied in CT, right? For any given problem, there are many different ways to solve it, right? There is some concept you might remember, something called as implementation and interface. Okay, so unless and until interface is accurate, implementation may vary from person to person, right? If I given a problem, you might have a different way of solving it. I might have a different way. Some other person might have even a third way to solve it, right? Which is absolutely okay unless and until your final answer is accurate. Correct? So
Yes,
all
sir.
these are correct implementations because they all give the correct answer.
Sir,
Yes,
implementation means the logic using in the code.
yes, correct.
And that's another
Interface.
thing.
Interface as in the overall look of it. I mean, at the top level, without looking at code, given an input, you are getting correct output. That's the interface.
The user what see.
Yeah, the what user sees.
Okay.
Internal details user is not interested. What user is interested? When I give some number, I should get accurate factorial of it. How you compute it, I don't care. That is interface.
Sir, is it same as a contract and procedure? Contract and what?
Yeah, kind of. Correct. So main contractor is not interested into how subcontractor is doing it. Unless until subcontractor gives a result back to me within time as accurate result, contractor is happy. How it is computed, contractor is not interested. Same thing.
Yes.
Okay. All right. So is this recursion part clear? Okay. Now I'll talk about that mutual recursion and then we'll move to DFS. Regarding that palindrome question, right? Well, I'll say what to do about it because palindrome question will have to write pseudocode, or maybe I'll just tell you how it is done. Okay. I don't want to deviate too much on that because there is one more concept remaining from this session, which is DFS. Okay. So first, mutual recursion. Okay. So who asked that mutual recursion?
Me.
Tarika, right? Yeah.
Yes.
Okay. So Tarika, what is mutual recursion? Mutual recursion is considered there are two procedures. Okay. Procedure 1 and procedure 2.
Okay.
Procedure 1 calls procedure 2 and procedure 2 calls procedure 1. That is mutual recursion. In standard recursion, what happens? The same procedure calls itself.
Sir, with the definition, I understand this with the definition.
Yeah.
But can you tell just one example? No need to tell in the pseudocode, but just one example where one procedure is calling to another and that procedure again call to that other procedure.
Okay. Fine. So consider like this. This factorial is only about multiplication, right? What if there is some mathematical function where multiplication is alone is not the operation. You do multiplication, then you do addition, then multiplication, then addition, multiplication, addition. So there is alternate operations are happening.
Okay.
Right? Then what you do? You do multiplication in one procedure, call the other procedure which is doing addition. As soon as that procedure do addition, it will call back the procedure with multiplication.
Multiplication. Okay. So we are doing alternatively multiplication and addition.
Correct. So any place where some alternate operations are happening, that is the place where you use this mutual recursion. Okay. Or for example, you are supposed to do some operation for odd numbers and some different operation for even numbers.
Okay.
Then alternately you will have to execute this, right? Because in a sequence, numbers will
odd and even number. That means one time I'm taking odd and another time I'm taking even.
I mean, in a sequence, you are iterating on numbers from 1 to 100. Naturally, numbers will come alternatively, right? Odd and even.
Yes.
So in such a case, you will have to use some mechanism like mutual recursion, or you will have to write a loop to iterate over it and check whether the number is even and odd, and accordingly call the respective procedure.
I got it.
Yeah. So these are the places where it can be used.
Only two procedure call or more than two means 3-4 procedure call itself. And
yeah, it's possible. It's possible. It can be as complex as you want. But usually my personal suggestion, avoid that because very minor mistake can result into a major problem, a major failure of the code.
So more than one procedure call without terminating one procedure is mutual recursion.
Yeah, without terminating one, you are calling other procedure, and that other procedure is calling original procedure. Okay, so it is. I'm not saying it's a mandatory or it's compulsion as such, but it's strongly recommended not to extend mutual recursion beyond two procedures. Okay, unless you are very sure about it and the code is well tested, then it's okay. Otherwise, it's recommended not to go beyond two procedures with respect to mutual recursion. And don't worry, everybody over here or anybody who will listen it to later on. In our in our syllabus, we just have mutual recursion at a conceptual level. Nobody is going to ask you any pseudocode in final exam or any time on mutual recursion. So don't worry about it. And that's why we never had that as part of any lecture or tutorial.
Sir, even in Python and PDSA?
In Python and PDSA, we will not be talking about mutual recursion. We will be talking about much at much broader level. We will be talking at concept level. How to implement it is up to you. Okay.
Okay, sir.
It's just a concept. As I said, recursion is implemented using two procedures, is mutual recursion. That's all. Whether to implement it or not, it's up to you. We will not explicitly ask you to implement in that manner anytime in any code, any course. Okay, because it's not something which is that important, which student must know. They must know how to code like that. That is not the case. So it is just the concept. You should know the concept. You know what it is, how it is done. That's more than enough at that level. More than that is not required in any course. Okay.
Okay, sir. Clear.
Yeah.
Sir,
what is PDSA?
Yeah. PDSA is one diploma course called Programming Data Structures and Algorithms using Python. So it's another course in diploma level. That's all.
Okay.
Yeah.
Sir.
Yes.
Sir, in the lectures, professors were discussing about explore train and that called explore station. That is also mutual recursion.
Yes, that was mutual recursion. I was about to mention that when earlier I gave that example, that in one, I don't remember, I mean, I wasn't able to recall exact lecture name and lecture number. That's why actually
fourth lecture.
The fourth lecture.
Fourth lecture, yeah.
Okay. Yeah. So in that lecture, there is a place where you find some information from train cards, you switch to station cards. From station cards, you get some information, you jump to train cards, right? Continuously, you are moving from one set to other set using that same mutual recursion concept. Okay. So it depends on the application. At some application, it is naturally a mutual recursive code. In some places, you can force it to become a mutual recursive code. But if it is naturally, then use it. Otherwise, better to avoid it, just to keep it simple. And as I said, we won't be asking any questions on mutual recursion for sure. So don't worry about that part. Okay. So palindrome of a recursive code for palindrome of a number, right? That I will come to it later. Okay. I think who asked it? I missed. I think Kajari, right?
Yes, sir.
Yeah. So I'll come to that later. Let me finish this presentation, this DFS part first. Then maybe if there is a time, we'll come to it. Okay.
Okay.
Sure. Because I'll refer to write pseudocode right here. So
I have pseudocode in practice assignment, I think.
It's already there, huh?
Yeah.
Okay, if it's already there, then we will come to that and we'll try to explain it.
Okay.
Okay. If not, then we can write it together. No problem. All right. So let's move ahead. Next part is DFS. So with respect to DFS, already in previous session, right, that solve with a session of week 11, I have explained pseudocode for DFS. So if somebody is interested in that, please refer to that session. So today I will not be talking about pseudocode, but I will be just referring to general process, how this recursively works, this recursion part of depth first search. Okay, so I will be talking about DFS at very abstract level. If anybody is interested in pseudocode, please do refer to that live session. It's called Solve with Us for week 11. I think it was conducted on Monday, if I'm not wrong, right? Others who were available,
Yes,
who were
sir.
there Monday, right?
On
Yeah.
Monday.
Yeah, so this week's Monday, so just a few days back. So please refer to that session for actual pseudocode. Okay, so let's take this example of a graph where there are 5 nodes and this 3, 4, 5 edges are there, and we are supposed to find the depth first search tree, correct? So when I say tree, every time whenever depth first search algorithm is executed, it is computed, input is always a graph and output is a tree. Okay, so let's start with a graph and build up towards that tree. Okay, and it is already given that the starting vertex is 1. So that means we should begin with from 1. So from 1 we will start our exploration. So from 1 there are 2 possibilities, right? Because 1 has 2 edges, 1 to 2 and 1 to 4. So we can choose to go from 1 to either 2 or 4. But there is something which we have decided upon, in our course, and that's even Professor mentioned in his lecture, that we will pick the vertex with smaller value. Okay, or if it's an alphabets, then alphabetically whichever comes before in that alphabetical order will follow that. So that in order to keep it uniform across all students. So from 1 we'll move to 2, correct? So our 1 is the starting vertex, and initially we do not have this. Okay, so the thing is yellow colored is the current vertex, and these green colored ones, the whatever color is, a blackish green, whatever is there, is these are the vertices which are not yet explored. Okay, these are unknown entities to us. As we keep exploring them, the colors will change and we will add them on the right side. So right hand side, we just have 1 node. This is the tree which I'm trying to build here. Okay. So on right hand side, I just have 1 node at the beginning, which is 1. Okay. That's my root node. Now, next step. Next step is what? At 1, it has 2 neighbors, 2 and 4, right? So now we know that there are 2 vertices, 2 more vertices. They are in these orange colored ones. These are the neighbors, and we have to pick one of them. So we pick 2. So as we have picked 2, 4 is not reachable now, right? Because from 2, 4 is not reachable. So 4 is unknown entity for 2. But for 2, now there are 2 known entities, which is 3 and 5. 1 is gone because 1 is something which we have done with and we moved away from. We might come back to 1 if required, but at this point we have moved away from 1. So 1 is done. So from 2 there are 2 possibilities. We as per our rule we will move to 3, and when we move to 3, 2 is done. We have moved away from 2, and at 3 there isn't any entity which we are supposed to reach to, because 3 has connection only to 2, and 2 is the one which we just visited, right? So it doesn't have any neighbors or unexplored neighbors, to be precise. Okay, it doesn't have any unexplored neighbors. So what should we do at this point? This is the point where we are stuck at some point. There is no going further. We cannot go ahead from 3. So there is only a valid possibility is to go back. So go back as in go back just 1 step. That's what we do. Whenever we go back always 1 step. So from 3, what is 1 step back? It's 2. So we go back to 2. So from 2, we explore 5, right? Because from 2, that was the only remaining vertex. So we explored 5. And at 5, now there is 1 new entity appeared, which is not yet explored, which is the next neighbor, which is 4. So we explored this neighbor 4 for that 5 and added it into tree. Now from 4, there aren't any unexplored neighbors. 1 and 5 both are closed, right? So we should go back one step, which is at 5. Once again at 5, there is nothing pending. So go back to 2. Nothing is pending. Go back to 1. Once again at 1, there will not be anything pending. So that will be our final tree. So that's the abstract way of implementing depth first search. Your input was a graph and your output is a tree. And every time any tree is constructed, it is a natural practice to add a node on the left followed by a node on the right. It's not mandatory, absolutely not, but it's, as I said, it's more like a recommendation rather than a rule. Okay, so we add one node on the left followed by a node on the right, and that is why after 1, when we added 2, we added on the left. When we added 3, we added on the left. We kept going depth, as in down the path, from first level to second level, from second level to third level. That's the depth. And at this point, we had one more node below 2. So we added that on the right. Once again, 4 was added below 5 on the left side. This left right, as I said, it's not that important, but it's a convention which is followed while drawing a tree in this pictorial format. Okay, so that is our depth first search, and yeah, that's the last slide. And as I said, it was just an overview of how the algorithm works in general. Okay, pseudocode you can refer to Monday's lecture, Monday's session. Yeah.
Sir, what if I go from 1 to 4? Then the tree will look like.
Yeah, the tree will look completely different, no?
Yeah, 1, 4, and
1,
5,
4, then below 4 there will be 5, below 5 there will be 2, below 2 there will be a 5. So it will be actually a straight, like it's straight line, right?
So that is also okay, sir.
Yeah, that is okay, no problem in that. But see, I'll tell you, depth first search can result multiple correct answers. Okay.
Yes.
Sir, in depth first.
Rohini, hold on. Let me finish.
Node which is of a lower number than the other one. No?
Hold on. Let me finish what I'm saying. So what I'm trying to say is, see, depth first search provides you a tree, depth first search tree, right? DFS tree. There are multiple such trees possible for any given graph. Okay, like you said, from 1, if we go to 2, and then from 2, if we go to 3 first, then this is the tree. But from 1, if we go to 4, 4 to 5, 5 to 2, 2 to 3, then it will be a straight line. 1 to 2, 2 to 1 to 4, 4 to 5, 5 to 2, 2 to 3. Like it will be almost like a straight line, a slope of from 1 to 3. That's one possibility. Another possibility, 1 to 2. From 2, instead of going to 3, I can go to 5 first. So then 5 and 4 will appear on left side. 3 will go to right side, something like that. So all these are valid depth first search trees. Okay. There is nothing wrong in it as per general pseudocode. But in our course, we have decided, see, all our questions are, computed by a computer system, right? It's not a manual evaluation. So there should be a standard answer which we should check. And that is the reason, Professor, and we have decided that we will stick to this particular rule, that if there is a tie, as in there are 2 neighbors, we will pick that neighbor with a smaller value. Okay, or the neighbor with which alphabetically comes first. So this rule you have to follow, at least for computational thinking, when you are answering any question with respect to DFS, to get the correct answer. Okay, because that's the something which we have assumed. It's an assumption. I'm not saying it's the standard rule. It's the assumption so that everyone will get the unique tree.
Okay.
Correct. Otherwise, the unique tree will not be possible. So that's the thing, Prashant. All right.
Sir.
Okay. Yeah, Rohini, no, you were saying something.
No, I just had to say that between 2 and 4,
Yeah.
because 2 is smaller number, we have to select according to the assumption.
Correct, correct. According to the assumption, right? So that's what I wanted to focus upon. It's like an assumption, but that's not the rule. Okay. Yes, Ritik, you have raised your hand.
So DFS does not give shortest path, neither give longest path. Then why
Right.
it is important?
Okay, so you're talking about applications of DFS, right? In that sense, you are asking about a DFS, right?
Yes, sir.
Okay. Is there anything which comes to your mind in this regard? Anything? I mean, it's there in the upcoming courses, but anyway, I mean, as you are on this topic, I don't mind discussing it. Anyone which anything, any place where DFS is useful, anything of that nature comes to your mind?
Sir, this course itself we are having, sir, Max. In Max 1, we are having all these things.
Okay, it's already there in Maths 1. Huh?
Yes, yes, it is there.
Okay, then
Graph
can you mention
11
at
and
least one
12.
application?
Yeah.
So
So
that,
it can be used for finding the trains between two stations.
And for checking connectivity.
Yeah, for connectivity.
correct. Connectivity is one possibility. What else? Yes, anyone?
Means what type of connectivity they are saying?
Okay, so what they are saying is, with respect to connectivity is, I was trying to look for some documentation if I have available with me from the upcoming courses, but anyway, it's not clearly there, which I can share directly. But anyways,
Sir, what was
in
that?
Maths it was introduced no reachability things.
Yeah. So connectivity or reachability is in this sense is, given a point, I mean, with respect to, let's say, our train data set, right? Given a point, can you reach to some point Y from point X or not? That's the point. So keep doing this depth, and can you reach from, let's say, 1 to 3 or not? There is no direct edge, but there is a possibility to reach from 1 to 3 if you go to 2, if you take this path 1, 2, 3.
Yes, sir, but
it may not be the shortest path. I agree. It may not be the shortest path, but the connectivity is there or not. It gives that answer.
yes, sir,
Sir, it is for connected graph only.
But BFS could also give the same thing and also tell that what will be the shortest connecting point.
Yes.
That's
correct.
why I wonder that why DFS is used too long in CT.
Okay, there are other applications of DFS also. Okay, it is not just about shortest. See, in a graph, shortest is not the only a goal. Okay, I mean, I actually wanted to avoid some applications, but I will tell you that these names you might not understand it. That's why I was trying to stay away from it. Just note it down if you are interested. Something called a cycle detection.
Basically, recursion, right now, sir?
Cycle detection.
Cycle detection is one of the applications that,
yes, sir,
given a graph, whether it contains a cycle or not. Okay, it can be easily detected using a DFS tree, using this DFS algorithm. I will quickly tell you this. I mean, this is straightforward. I mean, comparatively easier one to explain. So I will explain this one, even though it's slightly outside our syllabus. See, this is a tree. Okay.
Yes, sir.
And if there is any edge from a node, any node to node which is above it.
A back edge.
Yeah, it's something. I mean, yeah, the correct terminology again. Once again, I'm trying to avoid terms. It's called back edge. So if there is any back edge, then that's a cycle.
Okay, in original graph, if it is
in original graph, it's a cycle.
Or directed graph.
You get to the point. This point.
But in the output DFS tree,
Cycle or cliques, sir?
Not a clique. I'm not talking about clique. I'm talking about cycle. Cycle is different and clique is different. Guys, don't confuse. That's why I was avoiding discussing these concepts which are not in our syllabus.
Sir.
Okay, sir. Let's move.
So maybe Ritik, do one thing. post it on your respective forum. Maybe we take it there so that will not confuse others, right? And actually, it is coming. It's in that PDSA course. There will be entire week. We will be discussing about discussing on all these things.
Okay, then no problem, sir.
I mean, you might have seen, right? I opened some slides in between, right?
Yes, sir.
Yeah, those are the actual slides from PDSA course only. Okay. So it will come in depth.
Someone saying chess problem. It is also so, sir.
Sorry.
Someone in chat box written in chess problem.
Yeah, in chess problems also it is used. There is one very common famous problem called as n-queen problem. I don't know whether you heard about this or not. Something called as n-queen problem, which is again which is a common problem in algorithms which can be solved using DFS.
Okay,
so that's why I said, right?
PDFA, no?
In-queen problem, yeah, I think it's there. It's there. See, as I said, right, I can throw at you many such names, but the point is, I will end up confusing not just you, everybody around.
Yes, sir. Okay.
That's
sir,
why I'm just stopping myself right here. We'll discuss this at some later point. Okay.
Sir.
Yes.
You just said that the number, the node number which is above is usually smaller than the one which is at the lower place. But between 5 and 4, 4 comes down. So,
no, I never said that.
Acha.
I was talking something about that back edge and all that. Forget about it. That's not. It's not necessary that the numbers will be in incrementing order in the tree. No, not at all. It completely depends on the connections, right?
Okay.
Yeah. See, for example, consider now, Rohini, this. My starting node is 5. Then every number which is smaller will come below 5, right?
Yes.
So that doesn't exist. That kind of thing doesn't exist in DFS. Okay. Yeah.
So we will take 2, no? The smallest means if we start from 5, then we will.
Yeah, if we start from 5, then we'll go to 2. But what she was saying is something else. So it's clear for you, right?
I was talking about the output DFS tree which has been put over here.
Yeah. So it's not like that. That level wise it will be incrementing order and nothing of that nature. It purely depends on the starting point and the connections among these nodes. Yes.
Sir.
Yeah.
Sir.
Yes.
But you told that when 2 edges are there, we will choose the smaller one first.
Correct. Yes. Correct.
Yeah.
From the starting point, no?
Yes. Always from wherever you begin with. See, if there are 2 possibilities, 2 or more possibilities to explore, you explore the one with the smaller value. Okay. That's what we are following in the CT course.
Okay. Thank you, sir.
Sure. Thanks. Yes. Yes, Himanshu, you are on mute. Do you have any doubt? All right. So if all these things are clear, now let me address that previous question, which might help others also. So Kajari, can you mention where you saw that particular question so that I can directly pinpoint to that place and start from there? Kajari, are you there? I think she's not.
I do not think, sir. In participated in not, sir.
Okay, fine. Then maybe if she comes back, maybe we can discuss it later or whatever. Okay. Others, any doubt? Please raise your hand. Or I mean, now it's open. It's like now open session.
Sir.
Any doubts is fine. Yes, Tanushri.
Sir, I have a doubt outside the 11th week. Sir, I just got an email saying that today is the last day for week 12 assignment.
Okay.
But there is no week 12 in CT, no, sir.
Week 12 we don't have any assignments. It's fine. It must be a generic thing.
Okay, sir.
In week 12, there is even practice assignment is not there in week 12, right?
No, sir.
Yeah. So it must be a generic announcement for across all courses.
Reads for English.
Okay, it's for English.
Okay, sir. Thank you so much.
Sure, thanks. Okay,
Sir?
anybody else? Yes.
Sir, can you go to activity 10.2, question 4?
Okay. Hold on, let me open your city portal. Okay, activity. Why it's not loading?
10.2, question 4.
Okay, yeah, hold on. Yeah. 10.4.
10.2, sir, 10.2.
10.2. My bad. Question 4.
4,
okay.
sir.
Yes.
Sir, here graph can also be used to predict the delay of trains. So, sir, I didn't get it correctly. Means, how is it true?
Okay. How it is true? Okay. So I think correct answer is okay. Fine. Okay. Before that, I was just going through chat in between. Yeah. So as somebody was saying, right, it's not possible to derive graph from DFS tree, right? It's not at all possible. You can derive tree from graph, but not the other way around. I think Bhaskar mentioned in one of his sessions, and that's correct. Okay. So yes, so your doubt is what's your name? I missed
Sir, Prashant.
Prashant. Okay, yeah, Prashant. So you're talking about why this is true, right?
Yes.
Graphs
Sir.
can also be used to predict the delay of trains. Okay. This is it based on any specific previous data? No, right? Generally, generally what the discussion happened in lecture 2, correct?
Yeah. Yes, sir.
Okay. So in lecture 2, what professor discussed is because of some conditions, some situations, trains might get delayed. Correct?
Yes, sir.
Maybe there is a rain, there is a flooding, there is a maybe earthquake, or maybe some issue, right? Natural or unnatural, doesn't matter. But because of that, one train may get delayed. Our graph doesn't provide that information that I mean, we cannot predict the delay, but we can predict this part that if so and so train gets delayed, other depending trains might get affected. Which those depending trains are, that information we can predict, right? That these depending trains might get delayed. Not sure, they may or may not, but they might get delayed. But whether the delay will happen initially or not, that prediction graph doesn't have, right? Graph can just tell you connections. So if one train is delayed, its depending trains might be delayed, but we cannot be certain about that delay. And that's
what is depending trains means, sir? Depending trains?
Depending trains as in the connecting trains. See what usually how, I mean, I don't know whether you know this, usually how the train timetables are. Okay, if there is some major express coming from some station to your station, and then there are some local trains. So if that major express, major train is delayed, then depending on that, the schedule is changed in such a manner so that all these next trains, right, these local trains are also delayed based on that. Because what happens, the people who are coming from that express are supposed to get on to these next trains. And if they miss these trains, they may not have next trains. And that is why sometimes if one train, one major train gets delayed, all its smaller trains there onwards are delayed in order to accommodate those passengers. Okay.
Okay. Okay, sir.
So this is something which is followed across across Indian Railways, but that's the concept of these depending trains.
Okay. Okay, sir.
Okay, because the point is it's not that passenger fault, right? So it's a responsibility of railways to make sure that, so intentionally sometimes they delay the trains. even though there isn't any problem with those trains, because otherwise those trains may not even have passengers, because the passengers who are supposed to travel on those trains, they haven't arrived to that station.
Yeah,
and that's why this particular thing is followed.
Yeah, I understood this, sir, now, but this a bit confusing for the person who doesn't, because every time railway doesn't do like this.
Yeah, I agree. It's not every time, depending on, actually they look at the numbers and then decide it.
Yeah, yes.
I mean, depending on numbers of reservations and these dependency of major train, they decided. It's not a standard thing, but yeah, I understand. Actually, this was slightly discussed in the lecture 10.2.
Yeah, yeah, it was.
Yeah, right. Okay, so next, Naren.
So the palindrome she was talking about is in week 11 practice assignment, sir. Question number 2.
Okay, so you also have.
Sir, I have a doubt in this.
No,
in this
I
week, sir.
completed it just for your information. Anybody can have it now, sir. That's right.
Yeah, sure.
Sir, I have a doubt
so if
in this
anyone
week.
has a doubt with that question, maybe we can discuss it, or else we can move to somebody else's doubt.
Sir, week 10, I have a doubt, sir.
Hey guys,
Sir, I have a
please
doubt in this activity, sir.
hold on. If you have a doubt, raise your hand and wait for your turn. Okay, don't make it chaotic. Wait for your turn. There are people waiting before you. Yes, Tarika.
Sir, I have a doubt in practice assignment 10.
Okay.
Sir, question number 3. Sir, can you open the solution document as well?
Yeah, sure. You want question or solution document, so that accordingly I will open.
Sir, I want to see the solution document. I want to ask something about the line 7.
Okay. Sure.
Answer is line 7.
There is any mistake in solution document?
Sorry?
Is there any mistake in solution document?
No, sir. I have a doubt in that. Like the reason behind the reason which is provided, I want to understand that.
Okay, sure, fine.
Sir, sir, the error in line 3 is like it's understandable. I want to ask line 7.
What is the answer, by the way? What is the answer of this question?
Sir, line 3 and line 7.
3 and 7. Okay.
Yes.
Because I haven't even looked at the question, so I don't know. Okay, yeah.
Sir, in 7, it is said that it is not a it is not a matrix but a dictionary. That's why the key is used. But sir, I understand the keyword should be used, but why it is mentioned that it is not a matrix? Because Aij is a matrix, right? The error is because the key is not mentioned right here, the keyword key.
Correct. Okay, with line number 7. Where you read it in this? Is which paragraph?
Sir, in
next we introduce a variable train and
sir, yeah, the same paragraph last
part, right?
So here
Aij along with other keys of dictionary to find the train with minimum distance. So here for each key in rows of so and so is used, which is a mistake. Here Aij is a dictionary and not a matrix. Okay.
He is actually saying not about A. A is a matrix, not Aij is a matrix, I think.
Yeah. So
sir, I'm not getting that part actually. If Aij is there, then as per my understanding, it is a matrix, right?
No, it's not.
Aij is an element, not
matrix. Aij is an element of a matrix.
Sir, can you please explain this part?
Okay, see, A is a matrix, correct?
Okay.
But in that matrix, there will be various elements inside that matrix, right?
So that is the ith row and jth column. So
correct.
That particular
Ith row and jth column, there will be one element. Correct?
So they are talking about that particular element only.
Yes, we are iterating on that element. That element is, I think, a dictionary. Correct? As per this explanation, Aij is a dictionary.
Nested dictionary, yes.
Yeah, it's a dictionary. So at that particular level, in that Aij element, that is the combination of row, column, that cell, right? A specific cell is there. That Ij cell is a dictionary. And because of that, as it's a dictionary, you cannot use rows and columns function on top of it. You can use only keys on it, right?
Okay, got it, sir.
That's
okay, if it is a complete matrix, then only we can use. If they are talking about element, then
Correct. No, it's
Okay.
not about element or anything. See, you can derive rows or columns of a matrix, correct? You cannot
Yes,
have
not the
rows and
element.
columns concept with dictionaries. That's
Okay.
the idea. Okay.
Okay, sir.
We can have that element as a matrix also, but that is not the case here.
Yeah, that is not the case. But then
Okay.
you will not call it again. I mean, even in that case, Ritik, we will not call it a matrix. There is no concept of nested matrices. Okay.
Okay, sir.
Yeah. At least as far as I know. Otherwise, I mean, it doesn't make any sense. Otherwise, I mean, if you may have a nested matrices, it will be a 4D structure, right? Not 2D structure. And matrix is a 2D structure.
Yes, sir.
Yeah.
That
So,
whole
yes.
4D itself a matrix, we can say.
Yeah, then I mean, it's not a matrix. It becomes something else. Okay, anyways, Adnan, yes, go ahead.
Sir, practice assignment, 6th question.
Which practice assignment?
Week 10.
Week 10. Okay, 6th question. That question will come. Okay. According to you, what's the answer for this question? Yes, Adnan, can you mention? According to the options, these are the 3 correct answers. The first 3 are correct, last one is wrong.
But sir, I think there is a mistake in options.
Okay. Why?
Sir, from in option, you look at the second line, sir. BRK is equal to 1 and we should use actually direct K to C is equal to 1.
Correct.
But they have given both hops matrix.
Okay. So I'm still not clear on what your confusion is. Have you understood why
yes,
these
sir,
3
this question
are
is
correct?
Yes, sir.
Okay, so according to you, which is the correct answer for this question? Tell me that part.
Sir, I think there is not no correct option here.
Okay, you are saying all 4 are incorrect.
Yes, sir.
Okay, fine. So this question 6 is based on this information, right?
Yeah.
And
yes, sir. That's an hops problem.
Yes, it's a hop problem. So initially there may or may not be direct connection, but after one hop matrix execution, there is a possibility to go from I to J by visiting some node in between. Correct?
Yes, yes.
Not necessarily one node. We might visit multiple nodes also in between.
Yes.
Correct? Because that's the procedure which we are calling again and again depending on the value of hops.
Yes.
Correct? I mean, if we say 2 hops, then using 2 hops, we can go from I to J. If we
Yes,
say
sir.
5 hops, then using 5 hops, we can go from I to J. Correct?
Yes. Yes, sir.
So that's the idea behind it. Over here, what is happening is what you are saying, right? We are making BRC is equal to 1.
Yes.
When we are making BRC is equal to 1, when we find some train, some path from RK, and then from some path from R to K and then from K to C.
Sir, K to C a path should be direct path, I think.
Yes, K to C is direct path.
But we are using the matrix we after hops. I mean, there is if there is a path B and K with hop, then it will become. We are doing for 2 hops, but it will. But we get a matrix
what?
of.
Doesn't matter, right? It is path there or not. I mean, we want to construct that path, right? I mean, this is the filling the code question, correct?
Yes, yes, sir.
So whatever are at that point of time, whatever the value of B is, in that we have to keep appending these new paths, correct?
Yes, sir.
So this RK or KC, it doesn't matter whether it's direct or it's with one hop. If see what happens, this procedure get called initially for a very first time. That is the time B will be only direct matrix. And then with the any of these codes, we will make it a matrix with one hop. Correct?
Yes, sir.
When we execute this procedure second time, its input will be a matrix with one hop and its output will be a matrix with 2 hops.
2 up and 1 up both, no sir?
Yeah, I mean, it will add on to what existently it was there, right?
Yeah, actually, sir has told in math
Yeah,
video or
it's
CP
actually
video.
this is exactly the pseudocode which sir has discussed in his lecture. So
Sir has
Adnan,
told
what
that
is-
2 up will contain 1 up and 2 up both.
and direct also.
Sir,
Yeah,
if we
yeah,
use
Direct
this,
also.
sir,
Yeah.
if we use this code,
Uh-huh.
so if there is a one hop connection route between R and K,
Yeah.
A and C. So we are doing for 2 hops, but we will get, I mean, from R to K, if there is already a one hop,
Yeah.
and from,
Then what you are saying is it will become 3-hop matrix, right?
but we are doing for 2 hop there.
Yeah. Yes. Naturally, that will happen. That depends on how that RK or KC was generated initially. So that is okay. There is nothing wrong in it.
Okay,
That is how your matrix will grow.
okay, sir.
Yeah. So what you said is absolutely correct.
Thank you, sir.
And in fact, if you look at it even closely, right, as this number of iteration increase, number of hops also increase exponentially. It's not always +1. Right,
Okay.
Adnan? We might try for +1, but
Yes.
sometimes it might increase exponentially. Assuming there are already 3 hops and you are trying to add one more hop into it.
Yes, sir.
Then all those initial 3 hops may have internal hops as well, right?
Yes, yes.
Yeah, so that's what you said is absolutely correct. It's possibility. Yes, Prashant. Yes, Prashant. I think there are 2 Prashants during the session. Yes, Prashant. Go ahead.
Sir, while we enter that while loop, we'll start with direct matrix, sir, in this question.
Yes. While loop, which while loop? This one, na?
Yes, sir.
Yes. Yes, when we start it for the very first time, we start with direct matrix.
When we complete one loop, it will be for one of matrix we'll get.
Yes, correct. Correct.
Sir, I have another doubt. Sir,
yeah. Yes, tell me.
Sir, I have another doubt in activity question 10.2. Sir.
Okay. Yeah, question number. Shant, question number. You are on mute.
First question, sir.
Okay, first question. So according to portal, these are the correct answers. What is your take on this?
Sir, option C is not correct, sir.
Okay, so according to you, this third option is not correct, right?
Yes, sir.
Okay, let's see what's the scenario here. Okay. Okay, what we are talking about, consider the graph created in the lecture which represents whether 2 trains share a common station. If such a common station exists, then direct edge will be added between trains and that edge will be labeled with station name. Okay, so it's a bit different. Trains are nodes and edges are stations, right? And assume an edge is drawn between the trains A and B. The train B has in degree 1. Choose the statement or statements these are correct. Okay, right? The trains A and B share only one common station. Yeah, see what we say, the train B has in degree 1. If train B has in degree 1, that means what? B has
Sir,
only one edge.
Sir, I think question number 2 is a good example for this.
Okay, I'll come to question number 2, but let me first, I mean, I don't want actual data for this. So, Prashant, what is happening is B has in degree 1, right?
Yes, sir.
Now, what does that mean? There is only one station.
There's an edge from A to B.
Sorry?
There is an edge from A to B.
There is edge from A to B and B doesn't have any other edge, correct?
But
and
it can have out degrees.
Sorry?
Sir, but from B again, there can be another edge to A, no, sir, because they did not mention about out degree.
Okay, fine. Out degree is not mentioned. So what? What? But this still it remains true, right? The trains A and B share only one common station.
Sir, but from if there is another edge from B to A, then there is another common station for B and A, sir.
Okay, but then there will be edge from A to B also, right? See how our trains are. Trains are they run in
Can
parallel,
I say
right?
something?
Prashant, our trains are run parallelly. So if there is a train from A to B, there will be a train from B to A. There is a station on A to B, then there will be a station on B to A. Are you getting my point?
Okay, sir. It is not unidirectional.
No, our train data structure, the entire data set is like
Just
that.
at the beginning, they've written, consider the graph created in the lecture, which presents whether two trains share a common station. If such a common station exists, then a directed edge will be added between trains, and that edge will be labeled with the station name. So assume an edge is drawn between trains A and B. So I think the information given just before the question tells you a little more about the two trains.
Right. Prashant, maybe look at the graph which is
And when the
there in
train has
lecture
an end degree 1.
And
Yeah,
sir,
Rohit.
I want to say one thing.
Yeah, Prashant Raj.
In lecture, sir told that we will consider only those stations which are starting and ending point of a train.
Correct.
So there is no possibility of sharing two common stations.
No, here it is written that they share a common station.
Yeah, they do.
But only
share.
one. But only one. So same A and B cannot share two common stations.
No. If it's a common station, it is possible to switch from train A to train B.
Yeah. It is possible to have multiple common stations. That's not a problem.
No, sir. In lecture, it was not taken. This type of case was not taken.
Okay.
Here it is already given in the information. No? Use the below information from question number 1 to 3.
Correct.
And there it is saying that two trains share a common station.
Yeah.
So if there is a common station, then you can switch from one train to the other.
Yeah, but my point was that two trains A and B will share only one common station if there is any overlap, because it will only be the starting or ending point. So if train A ends at some station and train B starts from that station, then only there will be an edge from A to B.
There is no question of starting station over here.
So that's why this question is there, because
no, but in that, sorry to interrupt, but in that also we are where there is one common station because first train where it will reach, let's say it's going to Nagpur to Pune, so Pune and then Pune to Hyderabad, so the Pune will be the common station.
Yeah.
So in that way also it is correct, right?
See, I think, the way I am hearing it, Prashant Raj, Rohini and Tarika, you all are saying same thing. That how this option is given.
Yes, correct. Third option is correct. Yeah, yes.
Yes, everybody is saying option 3 is correct. So, I mean, you might have your own interpretation of it, but you all are saying third option is correct. So let's come to that part. So, yes, Prashant, have you understood why third option is correct? At the beginning, that's the place where we started.
No, I got this answer correct.
And that's what everybody got correct. So, except yes, Prashant. So, let me.
Because it is written already that they are sharing one common station.
Yeah, right. Correct.
So, the third option is correct.
Yes, that's what I'm saying. Third option is correct. And that's what everybody is saying. So
the first option I said is correct because B has in degree 1.
Yeah.
And A and B are sharing the station.
Correct.
That is why I got, I answered the first choice as correct.
Yes, yes, both are correct. First and third, these are the
Both are
correct.
correct, but
Yes.
I'm just saying that because they have one common station and B has one in degree.
Yeah, right.
That is why I
But
put
there will be
these
one
two
more
as
open session
possible answers.
after this class.
Okay, yes,
Means
yes,
if
Prashant,
it
is it clear? Is it clear
Sir,
for you?
I have one question.
Hey, hold on, hold on. If you have new doubt, please raise your hand. Let me close this
Because
session
I
one by
can't
one.
see the hand sign on my.
There is option. There is option called raise hand.
In
Actually,
the
you have to
reactions,
select more
in the in the reaction you can find.
Oh, reaction.
Yes.
Okay. So, yes, Prashant, are you able to hear me? Is it clear?
Yes, sir. I understand, sir. Yes, sir.
Okay. Okay. Great. Okay. So, yes, Ritik, you are saying something.
No, actually, I am saying, sir, there will be more doubt session after this.
After this, just check the calendar, no?
Miss calendar will update only for 1-2 days, no? Or
No, it's
this
already
long?
updated. It's whatever is there in calendar, that's final. There won't be any additional sessions on top of that. Yeah. Okay. Yes, Rohini.
So, I wanted to know something about click in a graph.
Okay.
Click in a graph.
Yes. So, what exactly you want to know?
No, I have not understood that part.
Okay. Is there any question where I can have a graph? Let me open some practice assignment. I'm hoping there might be some place where graph is there. Okay. Anyways, let me draw a graph. I think I have explained it in one of my previous sessions, but anyways. Okay, so is my whiteboard visible? This blank whiteboard?
I had a.
Is it visible? I just drew one node A.
Yes, sir.
Okay, yeah, it's visible, right? Okay. So assume this particular graph. I'm using mouse to draw, so it might be shaky, but try to understand what I'm doing. Okay, so I have these 4 vertices and let's draw some edges. I think this is the same example I have taken earlier. Okay. Okay. So, Rohini, there are 4 vertices and 4 edges. Okay.
Yes.
What is the definition of clique?
I did not get that.
Okay. The definition of clique is clique is a graph or a subgraph where every node is connected with every other node with an direct edge.
Which?
Okay. With an direct edge.
I didn't get it, sir.
Okay. For I'll tell you. Okay. For example, this is a graph, and I let's say if I consider a subgraph like this.
Okay.
ABD. This is a subgraph.
Yes.
And in this subgraph, every node is connected with every other node with a direct edge.
Directly.
Yes, directly. Then only it is considered as a clique.
Okay.
Okay. Because AD, AB, BD, all 3 are connected with each other directly. That's why this subgraph ABD forms a clique.
Okay.
Whereas,
okay.
Whereas this, for example, let's consider this one. Now tell me, is it a clique? BCD?
No.
No, right? Because CD edge is
C
not.
and D are not connected.
Yes, that's why this is not a clique.
Okay.
That's clique. Okay.
So can we say that clique only form in undirected graph?
Yes, you can. I mean, actually, the concept. I mean, you can say that okay, the clique is there in directed graph, but the application wise, we consider only undirected graphs for cliques. We do not consider directed graphs with respect to cliques. Okay, because it doesn't have any application as such.
Okay. So clique means complete graph, no?
No. Clique means a clique is not a complete graph. See, this is not a complete graph, but ABD is a
Part is
clique.
complete graph.
That's why I said a graph or a subgraph can be a clique. Okay. For a complete graph, there is no concept of subgraph. The whole graph can be a complete graph or it won't be a complete graph. You will not say, see, listen, you will not say the subgraph is complete. There is no such concept, but subgraph can be a clique.
So in this case, if D and C and A and C were connected, then it would be a clique.
Yes. So if I may write something like this, now it's a clique. Now the whole graph is, now the whole graph is clique. But
whole graph is
even a single edge makes it a regular graph, not a clique.
Sir, a complete graph is a clique, right?
Yes, complete graph is a clique. Correct. That part is correct. Okay. Is it clear? The clique concept?
Thank you, sir.
Sure. Thanks.
Thank you, sir.
Thanks.
Sir, clique is not for directed graph, isn't it? Sir?
We do not relate clique with directed graph. When we talk about clique, we consider only undirected graphs.
Yeah. Okay, sir. Thank you.
Okay. Yeah. Okay. Anything else? Anyone has any more doubts? What's the time?
The number of questions will be 15 about.
Yes. I don't know. We never announce number of questions or weightage. The given time is 1.5 hours. It's a 100 marks question paper. We will make sure that the given number of questions are solvable within 1.5 hours. That's something we can make sure of, but number of questions we don't know.
Sir, but the weightage we receive mail of maths about the weightage.
That's maths. I'm talking about computational thinking. At the beginning of this session, I spoke about weightage. Maybe you can hear to that later on YouTube. It's practically not possible to even derive or find out what's the weightage of week, at least in CT course, because the concepts are like that and the questions are framed in such a manner. See, if there is a graph question, it can have a dictionary and a list involved in it. Definitely, it will have if-else blocks. Definitely, it will have some functions. Definitely, it will have for and while loops. So, if there is a graph question, where exactly you will count it? Under graph, under list, under dictionary, under for, under while, what? So, practically, it's not possible. Right? It's an incrementative process in computational thinking. Every week when new concept involves, it inherently involves all the. So it's not even possible to calculate that weightage, at least in CT. So we never announce it. Not just this term, we haven't announced. This is the 6th term of CT. That's what we have done in last 5 terms, and that's what we will do in all upcoming terms as well. It's not possible. Okay. Yeah. Anybody else? Any other doubt? All sorted, ready for exam?
Sir, we will receive previous questions of previous week's questions also in enter.
Anything is any question can come. I cannot tell whether it will be from previous yes or no. It's anything is possible. There will be a question based on 12 weeks of content.
Means syllabus is from week 1 to 12, na?
Yes, syllabus is from week 1 to 12. There will be a question based on this syllabus.
And paper duration and its marks is also greater than previous week. That's why I'm asked.
Sorry?
Means that total marks of the paper is 100 marks. It's not 50. No?
Yes, 100 marks and 1.5 hours.
Okay, sir.
Okay.
Sir, can previous year questions be provided to us for practice?
I mean, we don't release it formally, but I think students have collected them, and there is some question bank out there as far as I know. So,
from where, sir? We don't
see.
There is one website, OpenNote. You can search OpenNote IITM on Google.
Yeah. I mean, there is some unofficial places there, but formally we don't release question papers. I mean, we will not provide you question bank like that. Don't expect that from IIT. Okay.
Okay. Ritik, can you give in chat?
Students can form their own question
Just
banks and
search on
circulate
Google
and do whatever you want.
OpenNote IITM. It will be first time.
Yeah. Okay.
And this is not just for this program. This is standard practice followed across all courses, all programs under IIT. Any IIT for that matter. Okay. Anything else? Okay, if not, then maybe we can close the session.
Sir, what have you asked Ritik to post?
Okay, he was asking about some applications of DFS.
Application for?
For depth first search.
Asha. But where can we find it?
You can search and you can find it on Google also. Just basic Google
No, where
search.
will he be posting it?
Okay. Where on the forum.
On the forum. Okay.
Yeah, on the forum.
Thank you.
In fact, to be honest, you don't even need forum for that. Just search this applications of DFS on Google. You will get the answer.
Okay.
So even for Ritik, I mean, you can. That's the best place, easiest and fastest place to look for any answers. See, for CT concept, it may not be useful, but these are standard algorithms. Okay, so if there is some standard algorithm or things involved, there are n number of resources available online.
Yes, sir, I get.
Right. So it's always the first place you should look is there.
Okay.
Okay. Yeah.
Okay. Thank you.
Sure. Thanks.
And so toughness of the next course that is coming, Python, that will be lesser than the CT or harder?
It depends on individual person, right? Whether, I mean, for me, I mean, the way I see it, it's easy. But see, in Python, the thing is, it's a specific programming language, right? So in Python, you will have, you don't have to worry about the pseudocodes and all that. You can always execute the code and check whether it was correct or not. So that makes life easier. But in order to do so, you should know how to write code. In CT, we never asked you to write even a single line of code. You were only used to select some codes from the given options. But in Python, we will ask you to write codes. There will be programming exams, dedicated separate programming exams, where we will give you some question. You are supposed to write a Python code for that question.
OPP.
Yes.
And so for that exam, we need broadband or mobile data will be enough?
That depends on your speed.
I mean, so how much data plan we have? We have only
plan. You don't have to worry about that. If you have a stable connection, it should work.
Just like in Zoom meeting we have.
Yeah, in a Zoom meeting, if it is working fine, then it should work even in that exam.
No, so if video recording of whole means camera will be there, then it will consume lot of data. If the slide video recording is consuming
for that we have something called as SCT. Before exam, we do some kind of system compatibility test. Okay, so during that you can check multiple connections and figure out which one works fine. Whether your existing connection is good enough or not. Okay.
Okay, sir. Because if suddenly we require broadband, then it will take time because we are in village, so broadband cannot be.
Yeah, I understand. I guess see if your mobile hotspot, your connection is
my connection is
good enough.
stable.
Yeah, if it is stable, then it should work. I don't see any problem in that. Okay.
So may I ask you a out of the context question? It's our favorite question, actually.
Yeah, sure. Go ahead. Anyway, the people are asking about Python when they
no,
are
sir.
not even past CT, but they are worried about Python. So
Since you take 3 of our courses, so what?
yeah, so far 3. Yes.
So if we want to buy a laptop, what should be the specifications like, so that we can, I mean, complete the course without any?
Yeah. Okay. So I'll tell you. We have taken this into account, and the way we have designed all the upcoming courses, right?
Yes, sir.
None of the courses will require you a specific configuration of your laptop. Okay. We make sure that whatever you do is available online, so that your local hardware configuration will not come into consideration. Of course, only one thing which is mandatory is internet connection. That has to be there. Without that, you cannot work. Okay. Other than that,
so we are moving to cloud then.
Yeah, kind of. I mean, not exactly cloud, depending on which
Is it
course it is.
Server, moving on server.
Yeah, moving on some online resource, right? Either it's a server, it's I mean, cloud is another kind of top.
I think like online only Google Chrome
but
supported.
we have made sure that we will provide you required softwares online, so that you don't have to purchase anything, and you will not have to purchase even some dedicated hardware. Any decent enough laptop should be enough. A desktop or laptop should be enough. Okay.
Okay, sir. Clear.
So I mean, we cannot force student to buy expensive hardware or softwares, right? So we have taken that into account, and that's how we have designed programs, and we will provide the necessary resources. If there is some software which is supposed to be purchased, then we will purchase it at a common level and circulate it for you. I mean,
So will you give any hint of that?
Or hint of?
Or is it, I mean, what kind of software or platform?
It's not required. I mean, see, that's what I'm saying. Either we use free softwares, and we design we have designed the courses around the free softwares, or just like Replit, right? You all can use Replit without any troubles, right?
But Replit can't handle, I mean, ML and all that.
It creates some problems sometimes.
Yeah, I agree. I'm not saying, I'm just saying for example, okay? I'm not saying Replit is the solution for everything. I'm not saying that.
Replit cannot handle, I mean, free Replit cannot handle ML. I mean.
Yeah, I agree. See, I'm saying for machine learning, they use Google Colab actually.
Okay.
Which is associated with your student account.
Okay.
Because all these student email IDs, what you have, they are from Google Suite. So all the applications or Google are already freely available for any one of you using your email ID, your student email ID.
Yes.
You may not have that email ID. Everyone may not have, because there are many people who are in first term. Once you start the second term, you will have email ID. Those who do not have as of now, you will get it from next term. So, right. So if there is some software required, we will make it available through your email ID. Okay.
Okay, clear, sir.
So you don't have to worry much about your hardware or software requirements, at least for this program. For your personal use and for your career sake and all that, you might have to think, but there is no hurry on it. Okay, you can take time and purchase it even later, even if it's required.
Okay, sir. Thanks.
And sir, beside this course, means beside this completion of course, would you suggest us to buy these resources or not?
Not required. I mean, as of for this program, not required. Otherwise, I mean, why to invest in something which is not immediately required? Okay. I mean, in future, once you start working in some company, they will provide you a machine. Okay. Whatever their requirement is, they will provide you a machine. Nobody will ask you to work on your personal machine for company purpose. So it's your personal decision. I cannot say either this way or that way, but if it's possible, buy it. But otherwise, I will say, I mean, it's not mandatory to have it. Okay. Now there are enough resources available online which you can utilize free of cost. So then your local hardware is not in picture. So you can go in that. All right.
Okay, sir.
Sir.
Yeah.
Sir, in that activity 10.2, if two trains share a common railway station, then they will not share another railway station, sir. They won't meet in another railway station. Is it correct, sir?
With respect to that question you are saying, right?
Yes, sir.
Yeah.
If A and B meet at Nagpur, they cannot meet in Mumbai.
Right. I mean, that's what the other person was talking about, right? We are considering only starting and ending stations, and that's the graph professors have considered in the lecture. So that's why I was earlier suggesting you, please go watch that lecture. I mean, not the whole lecture, at least the graph which they have considered. Okay. What exactly the constraints which they have put in on that graph, that part you consider, and then look at the question again.
Okay, sir.
Okay. Yeah.
Sir, I have one doubt.
Yes.
Sir, if we create a dictionary in a pseudocode, let's assume it is M. M is equal to empty dictionary. And then can we write between a pseudocode two keys? Can we write two keys?
Two keys as in?
Like I have mentioned one in one of line in initialization part matrix M is equal to one dictionary.
Okay.
Empty dictionary, and
my aim is empty dictionary. Okay, next.
Yes, and we have written something, and between this code I am writing M square bracket I
okay
square bracket J
square bracket
J
okay
is equal to something X.
Okay.
Yeah.
Okay.
So
you are saying whether this is valid statement or not, right?
Yeah. Yeah.
Okay. This is valid only if you have created M of I earlier. If you haven't, then it's invalid statement. You cannot create two nested keys directly. If you want to create this, then you should do something like this first. M of I is equal to empty dictionary. First you create first level key, then only you can create second level key. So this directly you cannot have without this line.
Okay, then it will be wrong.
Yeah, it will give error. I mean, if you execute this in Python, it will give error, or any language for that matter. I mean, in CT it's a pseudocode, so you can't execute it. But that's the point. You cannot create second level keys without creating first level key.
Yeah, sir, we can write this like M of I is equal to dictionary J as a key and value as X.
So this is what you are saying, right?
Yeah, it will be good?
Yeah, this is okay. This is good because you didn't create this J directly. You created I when you said this and assigned directly a existing dictionary to it, which is okay.
Oh, okay.
Okay, so this is also valid statement.
I thought both of them is okay.
Yeah, so either you have to do something like this or what we had earlier, right? Like M of I you create first.
Yeah,
and then you do M of IJ.
Okay.
Either this one you have, this approach is correct, or this approach. I mean, these two approaches are both are correct, but you cannot write only this highlighted line. If you write only this line, then it's incorrect.
Okay, sir.
Okay.
Okay, okay, sir.
Yeah.
Okay, thank you, sir.
Sure. Thanks.
Sir.
Yeah.
Sir, in practice assignment 11, question number 1, option A, and I have a doubt, sir. The question.
Sorry?
Sir, I have a doubt in practice assignment 11.
Practice assignment 11. Okay. Okay, hold on. Let's see. Give me a moment. Okay. Yeah, practice assignment 11, right? Okay. Question number
1, sir.
Okay. So this is the correct answer. Tell me.
Sir, I could not understand the difference between option A and D, sir. Both are looking same.
Okay. It's member listing limit analysis. Okay, the difference is this last part is not is just a element here, and it's putting in a list of, which is correct because for plus operator the both operands are supposed to be lists. But whereas this is incorrect because this last of L is not a list.
Okay, sir. Got it.
Okay. Yeah.
Thank you, sir.
Sure. Thanks. Okay. So it's done. Shall we close?
Yes, sir.
All right.
Thank you.
Sir?
Thank you so much, sir.
Thanks. Thanks,
Sir?
everybody.
Hello?
Yes. Yes, Vishwajit.
Yeah, so I've written something message, sir. So
Yeah,
can you
that,
reply?
Okay. It's a Python session. You're talking about Python in CT session.
Because there is no class left, so I mean.
For Python, there is one more on 8th.
Oh, you are going to, take that?
Yeah, I will be taking that on 8th.
Oh, okay, sir.
But why you want 90% plus? Why? I mean, what does it has to do with CodeChef?
No, so actually the question is like I didn't attend the quiz once, sir.
Yeah, I know.
Yeah, and I'm unable to attend that OPP one also, right?
Yeah.
But scored well in OPP 2, sir.
Right.
Yeah, so I have calculated. So even I score like 95% marks in NTERM. So it will be like till I am reaching 75 to 77 marks.
Okay.
So my target is to like I need to score more than 90 plus mark.
Okay.
In Python. So that like if I again apply for the betterment, sir, in next term.
You can.
So still my CodeChef mark will exist, or because I scored well in, I have submitted all the assignment in CodeChef.
Okay, see, if that is the case, you will see CodeChef we do not carry forward first. Okay. But for CodeChef eligibility, you do not even require 90 plus mark. It's just C grade, right? Minimum C grade, which anyway you will get even this time.
No, if I will get B. I mean 75. That means B.
Yeah, so that is C and above, right? So you will get your, if you are in toppers list of CodeChef this time, you will get CodeChef certificate this term itself, right? And this improvement you can do later. What's the problem?
Oh, okay. So I can next term I can I mean reapply for the improvement, right?
Yeah, next time you can apply for the improvement if you wish to.
No, because I'm on the list of top 30 students.
Yeah, if you are, then you will get certificate this term only, right?
Okay.
Chef has nothing to do with this. Code chef, we don't ask for 90 plus and all that. We just need C or above, which you will anyway will get, assuming you clear end term, and then there should not be a problem. I mean, this CGPA of Python you can improve later on whenever you want. I mean, I think not wherever you want. I think it has to be immediate term. If it's a improvement, it has to be in immediate term, I believe.
Yeah, improvement. That's what I'm saying.
Yeah, you can apply for improvement.
Still, I will get the code chef certificate. That is my question, sir.
That you will get right away after finishing this term.
Yeah, I will get a B plus mark in in this term. I'm confident about it. But the thing is that I will not get S mark. I mean A plus or F.
Yeah. For that you can do separate improvement, but code chef certificate you can have it immediately. I mean after the results are announced.
Okay, sir.
By this month end you will get that certificate if everything is right.
Okay.
Sir, certificates of what?
No, this is not related to CT. He is talking about Python, so don't worry about it.
Okay, sir.
Yeah. So you come to Python next term, we'll talk about it then. Okay.
Yeah. Okay, sir.
Yeah, sure. Okay. Thanks.
Thank you, sir.
Thanks,
Okay,
everybody.
thank you, sir. Good night, sir.
Bye. We'll close the session.